I'm Johnnie Lyman, and I'm a graduate student at the Scripps Institution of Oceanography, and I study rapid climate change in the Earth's past. I actually use stable isotopes to reconstruct climate from 55 million years ago, and I look at both cores from the deep ocean and rocks that were collected in Cedar Breaks National Monument, and we look at the limestone that makes up those materials, so calcium, carbon, and oxygen, and we look at the carbon and oxygen isotopes to help us reconstruct climate. This year's classroom was all chemistry students, and they were from 10th to 12th grade. They had all had biology as a class before this one, so we could use things that they had learned in biology to bring it into the chemistry that they were learning this year. In our lab, we take a lot of samples of sediment from off the coast of San Diego, and we look at how climate has changed here in California. And we took that knowledge into the classroom by showing the students a model of these deep sea cores using fluorescent beads. So they could actually look at how their little model cores of a fluorescent bead changed over time. And then we can talk to them about how that models the real cores that we use. We showed them fluorescent minerals, fluorescent beads, and any student, the instant you turn on a light and they see something glow and change color right before their eyes, they think, oh, that was odd. I didn't expect that rock to turn yellow suddenly when you turned a UV light on. So it catches their attention right off the bat because it's a result that's completely unexpected. So the second activity that we made was a culmination of an entire unit on gas laws that I actually got to teach this year. We actually had them acidify some limestone and have to predict how much gas would be produced based on the purity of that limestone. And they had to use their gas laws to figure out how big the balloon would get and then measure it to see if their experimental results matched what they got from the laws. So at the end of our lesson, we wanted to show students changes that were taking place here in San Diego, kind of a reason why they should care about climate change or about changes in their environment or basically the world around them and their local environment. So what we were showing them was a deep sea core from the coast of San Diego, and we showed them how lead had changed over time. So they can see lead going up and up and up, and then leaded gas was actually outlawed, and you can see lead going down and down and down. And they were really surprised that the year that leaded gas was banned, you could actually start to see a downturn in that lead data. So I think for a lot of them, they hadn't realized that when you put something into play on a national scale, when you say, okay, as a nation, we're going to stop doing something and we're going to change and we're going to do something else, you can actually see the environment respond almost immediately. And I think for most of them, it was surprising how fast that happened and that you could see it in a record from San Diego. It covers education standards from chemistry, biology, and earth science. So one of the things they have to learn for chemistry are parts of an atom. So we were talking about electrons and electron configuration. For biology, they have to look at how biological interactions take place over time and how the planet sort of interacts with organisms. For earth science, they have to look at the dynamics and the changing reservoirs that things can move through. So for instance, lead can wash off of land into the water and accumulate there. So these are kind of the basic ideas that we can get across with this type of lab. I think my favorite part of the Socrates experience is when I get to see that students have taken an idea that I've taught them about and they've processed it enough to start asking questions to help them learn even more about that subject. So when we talk to them about climate, they start asking, how do you get that research? How do you go out on a ship? What are the parts that you do to get this data that you have for us? I think the biggest thing that I've learned through this is how to build on an idea and start simple and to get something extremely complicated across to people that have never learned anything about that subject before. So in this case, how to take how people learned about chemistry through history and build that to how we learn about chemistry in a modern sense to how we got to this extremely complicated formula that they're now working with. I think that the Socrates program has helped me learn how to communicate in every way that a graduate student has to communicate. So we learn how to be on film, we learn how to talk in front of an audience, we learn how to write down our ideas about science in a way that anyone can follow. And I think any graduate student could benefit from that type of experience.